The southern deserts of Iraq become something entirely different after sunset. When the sun finally releases its grip, the scorched land cools slowly, almost reluctantly, as if holding on to the memory of heat. The air settles. Sound fades. And above it all, the sky expands into a vast, unbroken canvas. Thousands of stars appear, sharp and unwavering, stretching from horizon to horizon with a clarity rarely seen elsewhere on Earth. Even now, standing beneath that sky, it is difficult not to feel exposed. Small. Observed. This same sky hovered above humanity's first cities. 5,000 years ago, people stood on this very ground and watched these same constellations rise and fall. Yet when we examine the earliest written records they left behind, it becomes clear that they did not look upward with the innocence we often imagine. Their gaze was not driven by curiosity alone. It was driven by something heavier. Something more urgent. Their writings do not speak the language of wonder. They speak the language of caution. Modern history tells us that the Sumerians were the first civilization to systematically record the heavens. We are taught that they did so out of spiritual reverence, myth-making, or a desire to impose order upon chaos. That they named the stars as humans always do, to make the unknown feel familiar. But when their earliest clay tablets are read without modern assumptions, a very different interpretation begins to emerge. The sky, for the Sumerians, was not distant. It was not symbolic. And it was not safe. Again and again, their texts suggest that the heavens had already demonstrated their capacity for destruction. Not as a divine metaphor. Not as a moral lesson. But as a physical event with lasting consequences. The language is controlled, precise, and remarkably practical. It does not persuade the reader to believe. It assumes belief is already established. This raises an unsettling possibility. What if the Sumerians did not study the sky to understand it, but to survive it? The earliest cuneiform tablets recovered from sites such as Uruk, Eridu, and Sippar do not resemble the hesitant notes of a society just beginning to observe nature. There is no sense of experimentation. No visible learning curve. Instead, the record opens already mature. Planetary cycles are documented with confidence. Lunar intervals are mapped with consistency. Venus, the most complex planet to track without modern instruments, is followed with a precision accurate to the day. There are no explanations for why these movements matter. No introductory logic. No foundational theory. The tablets read as though they are continuing an existing practice rather than inventing a new one. This absence of explanation is one of the most revealing features of all. It suggests that the danger was already understood. A civilization does not reorganize its calendar, priesthood, and architecture around superstition alone. It does so around risk. The Sumerians tracked the heavens with the seriousness usually reserved for threats that have already revealed themselves. Their sky was not a source of inspiration. It was a system, one that required constant monitoring. When we compare this to the development of astronomy in other ancient cultures, the contrast becomes striking. Elsewhere, early star knowledge is vague and inconsistent. Calendars drift and require repeated correction. Constellations change names and positions. Knowledge evolves slowly, unevenly, visibly human. But Sumer is different. From the moment writing appears, astronomical knowledge is already refined. Venus cycles align perfectly. Planetary retrograde motion is recognized and recorded. These insights would not re-emerge elsewhere for centuries. There is no preserved childhood phase of this science. It arrives fully formed, as though inherited. That alertness permeates the language itself. Many Sumerian astronomical terms were long dismissed by translators as poetic or mythological. Phrases such as burning breath, evil wind, and stones of heaven were comfortably categorized as religious symbolism. Yet these same phrases appear alongside irrigation schedules, grain inventories, legal contracts, and mathematical tables. The same scribes who calculated harvest yields also documented celestial danger. This is not how mythology behaves. Myth exists apart from administration. Here, the cosmic and the mundane share the same clay. The same structure. The same urgency. The implication is profound. The sky was not separate from daily life. It was embedded into governance, travel, agriculture, and survival itself. Such integration only makes sense if sky events had produced tangible, devastating consequences within living memory. The Sumerians recorded times when certain stars were said to cross, scatter, or bring heat. They noted seasons when the horizon appeared to burn though no fire was lit. When winds arrived without clouds. When darkness lingered long after sunrise. These descriptions recur again and again, always tied to dates and cycles. They are not poetic flourishes. They are markers. Markers imply patterns. And patterns imply recurrence. Long before later cultures transformed the heavens into distant realms of fate and morality, the Sumerians treated the sky as something immediate and actionable. They assigned watchers. They established protocols. They constructed elevated platforms, not merely to honor deities, but to see farther, earlier, and more clearly. Their temples were not oriented randomly. They faced specific regions of the horizon, as though certain areas of the sky demanded constant attention. These were not monuments of blind faith. They were instruments of observation. To modern eyes, this vigilance can seem excessive. Today, celestial danger exists largely as abstraction. Asteroids are news headlines. Meteors are spectacle. Planetary defense is a line item in government budgets, discussed far from the night air. But for the Sumerians, the sky was part of the environment. No different from rivers that flooded or winds that stripped fields bare. Except rivers announce themselves. The sky does not. To watch the heavens is to accept that destruction can arrive without warning from a direction no wall can block. If fear was embedded into Sumerian cosmology, it was not irrational. It was shaped by observation and loss. Their gods did not merely rule the sky, they emerged from it. They carried fire. They scattered fragments. They brought seasons of dust, silence, and collapse. These were not moral stories. They were environmental memories. Across the ancient world, similar narratives appear: fire from above, darkness without storm, sudden devastation followed by long recovery. Yet Sumer stands apart in one crucial way. They did not stop at telling the story. They measured it. They tracked it. They transformed memory into mathematics. This suggests a civilization haunted not by a single catastrophe, but by the knowledge that catastrophe could return. Again. And again. What does it mean for a culture to believe that the sky itself follows cycles of danger? It means that every generation inherits not only land and language, but responsibility. Someone must keep watch. Someone must maintain the count. Someone must remember what happens when vigilance fails. The Sumerians understood that memory is fragile. Clay cracks. Cities fall. Languages vanish. Their texts are written with an urgency that assumes forgetting is inevitable. Perhaps that is why the warnings are repeated across centuries. Not because the scribes lacked imagination, but because they feared forgetting more than repetition. Sometimes the most important part of a message is not what it says, but what it assumes. The Sumerian tablets assume that the sky can kill. They assume it has done so before. And they assume it will do so again. They were not writing for comfort. They were writing against time. If the Sumerians already possessed this level of certainty at the very dawn of civilization, then the real mystery is not what they believed. But what had happened before them that made such vigilance unavoidable? When archaeologists first began excavating the ruins of ancient Sumer, they expected to uncover a story of gradual beginnings. Rough tools. Simple structures. Early experiments in social organization. This is what the birth of civilization normally looks like in the archaeological record: hesitant, uneven, visibly learning through trial and error. That is not what they found. Instead, layer by layer, the soil revealed something deeply unsettling. Refinement stacked upon refinement. Precision where uncertainty should have existed. systems already standardized at the moment they first appear. It was as though the opening chapters of the story had already been torn away, leaving civilization to emerge mid-sentence. At Eridu, often described as the oldest city in the world, archaeologists expected the lowest layers to reveal primitive beginnings. What they uncovered instead were temples already aligned with astronomical precision. Mathematical notation already consistent. Architectural choices that made little sense for climate or defense, but perfect sense for observation. There was no simpler phase beneath them. No experimental foundation. Just repetition and adjustment, as though something older was being carefully maintained. In most civilizations, knowledge leaves fingerprints of its own development. Early calendars drift. Star names change. Measurements contradict one another. Corrections accumulate as errors are noticed and repaired. This is what learning normally looks like: human, imperfect, transparent. The Sumerian record does not behave this way. From the moment writing appears, it arrives already capable of encoding law, commerce, medicine, poetry, mathematics, and astronomy. The cuneiform system does not evolve slowly from crude markings. It appears structurally mature, flexible enough to describe both mundane administration and complex celestial movement. Even more unsettling is the nature of its astronomical vocabulary. The earliest tablets already distinguish between fixed stars and wandering planets. They recognize irregular motion. They categorize celestial events by consequence rather than appearance. This is not the language of beginners. One of the most frequently cited examples of Sumerian astronomical sophistication is their star catalogues. But what matters is not merely their accuracy, it is their confidence. The catalogues do not explain how the stars were identified. They do not justify why certain cycles matter. They state them as facts long agreed upon. Rising times are listed with seasonal regularity. Constellations are fixed. Planetary paths are tracked with consistency that modern simulations have verified as accurate for the period. Accuracy alone is impressive. But accuracy without explanation is revealing. A culture discovering astronomy would celebrate discovery. It would preserve uncertainty. It would record debate. It would mythologize disagreement. The Sumerians preserve none of this. Their texts read like maintenance manuals, updates to an existing system rather than records of first discovery. As though their task was not to learn the sky, but to keep its record intact. This pattern extends beyond astronomy. Sumerian mathematics appears already optimized for cyclical calculation. Their base 60 number system is not intuitive for daily counting. It is cumbersome for simple arithmetic. Yet it is extraordinarily powerful for tracking fractions, angles, and repeating intervals. It is ideal for astronomy. It is ideal for calendars. It is ideal for long-term cycles that require precise subdivision. Why would the world's first civilization choose such a system unless cycles mattered more than convenience? At sites such as Uruk and Nippur, early administrative tablets sit beside astronomical ones, sharing notation, structure, and scribal style. This suggests that the same institutional framework managed both earthly and celestial matters. Grain inventories and star movements were part of the same accounting logic. The implication is subtle but profound. The sky was not a subject added later to an already functioning society. It was foundational, built into the administrative spine from the very beginning. Architecture tells the same story. The earliest temple layers at Eridu, dated to well before 5000 BCE, already exhibit orientation choices that make little sense for climate, defense, or trade. Instead, they align with specific horizon points associated with stellar risings. These alignments persist through multiple rebuilds, adjusted slightly over centuries. These adjustments are not random. They compensate for precession, the slow wobble of Earth's axis that causes the apparent positions of stars to drift over time. Precession is subtle. It cannot be detected within a single lifetime. To recognize it, observations must be compared across generations. Someone noticed the drift. Someone corrected for it. This means the temples were not static monuments. They were instruments, recalibrated over centuries to remain accurate. Each rebuild was not an act of tradition alone, but an act of maintenance. This implies continuity far older than the buildings themselves. Sumerian king lists hint at this inheritance in an oblique way. They describe rulers who reigned before the flood, whose lifespans stretch into impossibility. Modern readers dismiss these figures as mythological exaggeration. But within the logic of the texts, these long reigns serve a purpose. They compress memory. They bridge eras. They preserve continuity across catastrophic breaks. Time itself becomes a tool. If the Sumerians did not see themselves as founders but as inheritors, their sudden sophistication becomes less mysterious. They were not inventing civilization from nothing. They were reconstructing fragments of a system that had existed before memory fractured. This interpretation reframes the most famous question of Sumerian origins. Instead of asking how civilization began so suddenly, we asked something far more unsettling. What was civilization rebuilding from? The star catalogues do not read like discoveries. They read like restorations. And restoration implies loss. In later texts, Sumerian scribes occasionally use phrases translated as from before or according to the old count. These references appear without explanation, as though their meaning were obvious to the intended reader. They point to standards that predate the tablets themselves. Measures older than the cities in which they were written. One inscription from Sitpar describes a temple not as a creation, but as the restoration of what was before, something damaged, not something new. This language appears again and again, quietly contradicting the narrative of first invention. The deeper archaeologists dig, the more elusive the beginning becomes. There is refinement everywhere, but no origin point where refinement gives way to experimentation. One French archaeologist working at Lagash once remarked that excavating Sumer felt less like uncovering a birth, and more like digging through the aftermath of something. If that is true, then the Sumerian obsession with cycles takes on new meaning. Cycles are not comforting to those who have only known growth. They are terrifying to those who have known collapse. A society that believes destruction returns does not celebrate linear progress. It measures time differently. It counts. It watches. It prepares. And it teaches its children not just how to build, but how to remember. Memory, in this context, is not nostalgia. It is infrastructure. The Sumerians built that infrastructure into writing, mathematics, architecture, and ritual. They created systems designed to survive kings, droughts, invasions, and even the forgetting of their original purpose. Because the danger they were tracking did not care whether anyone remembered it. It would return regardless. This raises a more uncomfortable possibility. If the Sumerians inherited astronomical knowledge already refined, then someone before them had reason to refine it. Someone experienced the sky not as pattern, but as threat. Someone watched long enough to recognize recurrence. And someone ensured that recognition did not vanish when their world did. The Sumerians may not have known the full story of that earlier catastrophe. But they knew enough to take it seriously. Enough to build their civilization around vigilance rather than optimism. To understand what taught them that lesson, we must turn to the texts we have long dismissed as metaphor, stories of fire, wind, and darkness that appear across cultures. Stories that, when read without modern assumptions, begin to sound less like imagination and more like compressed memory. The next layer of this story does not lie in the sky or in stone. It lies in language shaped by fear. Language that may carry the testimony of a world that did not survive to tell its story any other way. If Sumer was rebuilding rather than beginning, then the true origin of this knowledge lies buried deeper than any city, in an event so destructive that it fractured civilization itself, yet left scars the earth still remembers. There is a moment in every serious investigation of the ancient world when language begins to fail. The symbols are familiar. The grammar is understood. The translations are technically correct. And yet, the meaning refuses to settle comfortably into the categories we have assigned to it. What was once labeled myth begins to resist that label. The words refuse to remain symbolic. The stories stop behaving like stories. For decades, scholars translated Sumerian texts that spoke of fire falling from the sky, burning winds, and stones descending from the heavens, and then quietly moved on. These passages were filed alongside epics and hymns, interpreted as metaphor, moral instruction, or divine drama. Early cultures, we were told, personified nature because they lacked science. They explained disaster through gods because they did not understand natural law. That assumption became a filter. Anything that sounded too catastrophic was softened into allegory. But when these texts are read closely, not as literature, not as theology, but as records, something begins to break through that filter. The language does not behave like imagination. It behaves like testimony. Consider the Omen series known as Enuma Anu Enlil. These tablets are often described as astrological superstition, collections of signs linking celestial events to earthly outcomes. But their structure is not poetic. It is conditional, diagnostic, procedural. When this happens, then that follows. This is not the structure of myth. It is the structure of analysis. Each celestial event is paired with a terrestrial consequence. Not vague fate, but specific outcomes: famine, darkness, silence, abandonment. The texts do not dwell on emotion. They do not describe terror, guilt, or divine anger. They describe effects. One tablet recovered from Sipar describes a time when the wind came without clouds and the sun dimmed though no storm was present. Another warns of a season when stones of fire crossed the sky and the fields failed for years afterwards. A third records the day the horizon burned, a phrase that appears nowhere else in Sumerian literature except in reference to celestial danger. These phrases are not explained. They are referenced as known phenomena. This distinction matters. Myth expands. It embellishes. It repeats with variation. Eyewitness memory compresses. It strips experience down to what mattered most: heat, light, sound, duration, consequence. When Sumerian scribes wrote of the burning wind, they did not describe fear. They described aftermath. Crops failed. Cities emptied. Travel ceased. The emotional content is absent. The practical outcome is not. And this pattern does not exist in Sumer alone. Across the ancient world, similar descriptions appear with unsettling consistency. Egyptian texts speak of a time when the sky rained fire and the sun hid its face. Hittite myths describe stones falling from above and the earth trembling for days. In Mesoamerican codices, the world ends not with water alone, but with fire from the sky before the flood arrives. These cultures were separated by oceans and millennia. They did not share language, politics, or religion. Yet their disaster sequences align with disturbing precision. First, light without thunder. Then, intense heat. Then, darkness that lingers. Then, famine. Then, flood. This sequence does not describe an ordinary storm. It does not match the behavior of seasonal floods. It does not resemble volcanic eruptions as ancient observers would have experienced them. But it does resemble something else. Modern science now recognizes that large cosmic objects entering Earth's atmosphere do not need to strike the ground to devastate entire regions. Many explode mid-air, releasing energy equivalent to multiple nuclear weapons. These airbursts produce an intense flash, extreme heat, and a powerful shockwave. In the weeks and months that follow, fine debris can spread through the atmosphere, dimming sunlight and disrupting climate. To a pre-industrial observer, this would appear exactly as described in the ancient texts: fire from the sky, followed by darkness. One Sumerian tablet mentions the day when the river steamed and the fields turned to glass. For generations, this was dismissed as metaphor. But vitrified soil, sand fused into glass, is a known byproduct of extreme heat events. It cannot be produced by ordinary fire. It requires temperatures reached during lightning strikes or cosmic impacts. Another text warns that after the sky event, no grain would grow for 7 years. Not forever. Not as a curse. A measured duration. 7 agricultural cycles. Myth exaggerates. Records constrain. When researchers began comparing the dates associated with these omen texts to climate proxy data, unexpected correlations emerged. Ice cores from Greenland record periods of abrupt cooling. Sediment layers show spikes in atmospheric dust. Tree ring records reveal sudden growth suppression. Many of these anomalies cluster around periods referenced in Near Eastern disaster traditions. The alignment is not perfect. Ancient calendars shift. Dates erode. But the pattern persists. Catastrophe. Darkness. Recovery. Then, generations later, disruption again. What is most striking is what the Sumerians do not say. They do not moralize these events. They do not frame them as punishment for sin. The sky is dangerous, but not judgmental. It behaves mechanically, predictably, indifferently. This worldview is incompatible with pure mythology. Myths explain meaning. These texts explain risk. The language reinforces this interpretation. Sumerian grammar distinguishes clearly between recounting the past and forecasting the future. In many omen tablets, the future tense dominates. When the star crosses. When the fire appears. When the count completes. These are not stories of what happened once. They are warnings of what happens when conditions repeat. The scribes were not preserving legends. They were preserving scenarios. This reframes even the most famous Sumerian narratives. The Eridu Genesis, often treated as a flood myth, does not begin with water. It begins with disturbance in the heavens. Fire and wind precede flood. Darkness precedes rebirth. The flood is not the cause. It is the consequence. Across cultures, the same sequence appears. Fire from above, then long darkness, then water. This is not how rivers behave. But it is how climate behaves after an atmospheric catastrophe. An impact winter would suppress evaporation and alter weather patterns. Ice sheets would expand. Meltwater would later surge, overwhelming low-lying regions. To survivors thousands of years later, these events might collapse into a single remembered cataclysm. But traces of sequence remain. The Earth preserves that sequence differently than stories do. It keeps its record not in words, but in layers. Thin seams of darkness pressed between sediments. Microscopic spherules of melted material. Nanodiamonds formed only under extreme pressure. For much of the 20th century, geology told a relatively calm story of the past. Climate shifted slowly. Ice ages advanced and retreated over millennia. Change was gradual, predictable, almost comforting. Then researchers encountered something that did not fit. A boundary. Thin. Black. Global. At sites across North America, Europe, and the Middle East, geologists identified an unusual layer dating to approximately 12,800 years ago. It was rich in carbon, filled with melted microspherules, and laced with nanodiamonds. These were not the signatures of wildfire. They were not volcanic ash. They pointed to extreme pressure and heat. The Younger Dryas impact hypothesis emerged from this anomaly. It proposes that Earth experienced a sudden cosmic encounter at the end of the last ice age, not a single crater, but a swarm of fragments entering the atmosphere, exploding in a series of airbursts across the northern hemisphere. The immediate effects would have been devastating. Continent-scale fires. Shockwaves flattening forests. Massive loss of life. In the months that followed, atmospheric dust would have dimmed sunlight, plunging the planet back into near-glacial conditions for over 1,000 years. Ice cores record this abrupt cooling clearly. Oxygen isotope ratios shift sharply. Temperatures drop within decades. Megafauna vanish almost simultaneously. Human cultures fragment. The world resets. One archaeological site bridges this geological evidence with human experience, Abu Huraira in modern-day Syria. Excavations revealed a distinct burn layer dated precisely to the onset of the Younger Dryas. Within it, researchers found melted building materials and glass-like carbon formations requiring temperatures far beyond any known ancient fire. For the people living there, the sky would have become an instrument of annihilation in seconds. When this geological timeline is placed alongside ancient Near Eastern texts, the correspondence becomes difficult to ignore. Sumerian writings speak of a time they call before the waters. A world that ended violently, followed by darkness, then flood. Fire first, then water. If the Sumerians inherited memories of such an event, their fixation on the sky suddenly makes sense. The flood was not the beginning of destruction. It was the aftermath. The sky was the trigger. The Younger Dryas was not merely a climate event. It was a cultural rupture. Knowledge was lost. Population densities collapsed. Survival replaced innovation. In such a world, the lesson that mattered most would be simple and terrifying. The sky can do this again. If that lesson survived, it would survive not as explanation, but as priority. Watch the sky. Track its cycles. Never assume safety is permanent. The Sumerians appear thousands of years after the Younger Dryas, yet they behave like heirs to a trauma they did not personally witness. Their texts do not describe the event in detail. They reference it obliquely, as something known. Before the waters needs no explanation. It is a shared point in deep time. This leads to an uncomfortable possibility. What if the Sumerians were not speculating about cosmic danger at all? What if they were responding rationally to a geological memory preserved across generations? Geology hints that the Younger Dryas was not unique. Other, smaller disruptions appear throughout the Holocene. Dust spikes. Cooling events. Abrupt societal collapses. Not as severe, but recurrent. The Earth stacks these scars. If ancient observers recognized that catastrophe clustered rather than occurring randomly, then their obsession with cycles was not superstition. It was pattern recognition. And if the sky follows cycles of danger, then the most important knowledge a civilization can possess is not technology, but timing. If the Earth itself remembers repeated encounters with fire from the sky, then the Sumerians were not watching the heavens in fear, they were watching it on schedule. And to understand what they were waiting for, we must now follow their gaze beyond myth and geology into the mechanics of the sky itself. To ancient observers, the night sky appeared eternal. Stars rose and set with reassuring regularity. Constellations returned each year in familiar patterns. Against this backdrop of apparent permanence, sudden flashes of light, meteors, fireballs, streaks that tore through the darkness, seemed like interruptions rather than structure. Most cultures treated these events as omens or curiosities, unpredictable and brief. The Sumerians did not. They watched them closely. Modern astronomy now understands something that ancient sky watchers could only infer through patience and memory: the sky is not random. Earth does not move through empty space. It travels through vast streams of debris left behind by comets and fragmented celestial bodies. These debris fields wrap around the sun like invisible rivers, intersecting Earth's orbit at predictable intervals. Each year, as our planet passes through these regions, the atmosphere ignites. Most of the time, the particles are small. They burn up harmlessly, producing meteor showers admired for their beauty. But these streams are not uniform. Within them lie dense filaments, clusters of much larger fragments. Some are meters across. Others are hundreds of meters wide. When Earth encounters one of these denser regions, the consequences can be catastrophic. One of the most significant of these debris systems is the Taurid meteor complex. Unlike short-lived meteor showers that peak sharply and fade, the Taurids are broad, slow, and persistent. Earth encounters them twice each year, once during the daytime in late June and early July, and again at night in late October and early November. The meteors appear to radiate from the constellation Taurus, near the Pleiades, a region of the sky the Sumerians tracked with particular care. The Taurid complex is not a simple stream. It is the remnant of a massive comet that fragmented tens of thousands of years ago. That fragmentation produced a sprawling debris field so extensive that Earth has been passing through it ever since. Most encounters are uneventful. But embedded within the stream are concentrations of material capable of producing devastating airbursts. Modern examples demonstrate the danger. In 1908, a large object exploded over Tunguska in Siberia, flattening more than 2,000 square kilometers of forest. No crater was left behind. The object disintegrated in the atmosphere, releasing energy comparable to multiple nuclear weapons. In 2013, a smaller object detonated over Chelyabinsk, Russia. The shockwave shattered windows across 6 cities and injured over 1,000 people. Once again, there was no impact crater, only atmospheric destruction. Both events occurred during Earth's passage through the torrid stream. To modern observers, these incidents are treated as rare anomalies. To the Sumerians, they may have been part of a known pattern. The constellation Taurus occupies a central position in Sumerian cosmology. The bull of heaven is not merely symbolic. In multiple texts, the bull is associated not with fertility alone, but with devastation, judgment, and sudden destruction. When the bull rages, cities fall. Fields fail. Silence follows. This duality has long puzzled scholars. But from an astronomical perspective, it makes sense. The same region of the sky that brings seasonal renewal also carries risk. The bull does not always destroy. But when it does, the consequences are severe. The Taurid meteors are unusually slow compared to other meteor streams. This makes them particularly striking to naked eye observers. Their fireballs often last several seconds, fragmenting visibly as they cross the sky. To someone watching night after night from a raised platform, these events would stand out. They would be memorable. They would invite tracking. The Sumerians did not need telescopes to recognize that some seasons brought more fire from the sky than others. They needed only continuity. Over generations, patterns would emerge. Certain months produced more fireballs. Certain stellar configurations coincided with disruption. And occasionally, something far larger would appear, a brilliant object bright enough to cast shadows, followed seconds later by a thunderous shockwave that flattened walls and ignited fields. Such events would not be forgotten. The Taurid complex presents another challenge that makes it especially dangerous. Many of its objects approach Earth from directions close to the Sun. During the daytime stream, they arrive out of the glare of daylight. During the nighttime stream, they emerge from twilight, the most difficult time to observe the sky. Even modern telescopes struggle to detect objects approaching from these directions. The Sumerians understood this vulnerability intuitively. Their texts emphasize watching at dawn and dusk. Their rituals cluster around transitional light. Their temples frame the eastern and western horizons during precisely these times. This was not coincidence. It was strategy. If a civilization believed the sky could strike again, it would focus attention where warning time is shortest, where danger emerges without ceremony. Modern orbital simulations reveal something ancient observers could not calculate but may have inferred. The density of the Taurid stream fluctuates over time. Gravitational interactions, particularly with Jupiter, shepherd debris into clumps that drift and disperse over centuries. When Earth intersects one of these dense filaments, risk increases dramatically. These intensification periods recur on timescales measured not in decades, but in millennia. To detect such cycles requires observation across generations, longer than any single human life, longer than most civilizations endure. Yet the Sumerians tracked long counts. They measured cycles that exceeded political timelines. They embedded numbers into their astronomy that make little sense for agriculture or ritual alone. Seen through this lens, their behavior becomes logical. They were not predicting individual impacts. They were monitoring probability. The bull of heaven ceases to be a mythological creature. It becomes a celestial marker, a warning sign in the sky, indicating the region Earth must pass through again and again. Most of the time, nothing happens. But sometimes, something does. And if ancient humanity lived through one of those times, the memory would not fade easily. It would become encoded into stories, rituals, architecture, and mathematics. It would shape a civilization that did not trust the sky to remain harmless. This is where Sumerian astronomy diverges sharply from later myth-centered traditions. Their focus was not on individual stars, but on regions of danger. Their concern was not beauty, but timing. They were not mapping the heavens for philosophical meaning. They were mapping risk. This explains why their temples and observation platforms were so carefully oriented. They were not honoring the sky in general. They were watching specific corridors of space. Modern science now confirms that these corridors exist. Earth's orbit intersects debris streams at predictable times. Most encounters are minor. But history suggests that occasionally, conditions align badly. If the Sumerians recognized this pattern, even imperfectly, then their entire civilization begins to look like a response to orbital mechanics rather than superstition. They were not predicting the end of the world. They were watching a schedule. The implications are unsettling. A sky that behaves cyclically is far more dangerous than one that behaves randomly. Random disasters can be dismissed as bad luck. Cyclical ones demand preparation. The torrid stream is not the only debris system Earth encounters. But it is one of the largest, slowest, and most persistent. Its very structure makes it capable of producing repeated regional catastrophes without leaving obvious craters. This may explain why ancient accounts describe devastation without impact scars. Airbursts flatten cities without gouging the earth. The damage is immense, yet geologically subtle. Memory, not stone, becomes the primary record. If the Sumerians were correct in identifying the Taurids as a recurring threat, then their obsession with cycles, counts, and long-term vigilance was not paranoia. It was adaptation. They lived in a world where the sky occasionally reminded humanity of its vulnerability. A world where progress could be undone in minutes. A world where survival depended not on prediction, but on readiness. Which brings us to the most disturbing aspect of all. If these cycles exist, and modern data suggests they do, then they do not belong to the past alone. They are ongoing. The torrid stream has not disappeared. Earth still passes through it. The debris still drifts. The filaments still shift. And once again, according to modern simulations, Earth is entering a denser region of that stream. The Sumerians believed that danger returned on schedule. They believed the sky followed cycles. And they believed forgetting was the greatest risk of all. If the Sumerians were tracking a long celestial cycle, one that modern astronomy is only now beginning to confirm, then the final question is unavoidable. Did they encode the timing of the next danger into their numbers, and are we living closer to that moment than we realize? At first glance, numbers appear harmless. Neutral. Detached from fear or memory. They are the language of trade, architecture, and administration. In ancient Sumer, numbers counted grain, measured land, and organized labor. This is how civilization is supposed to begin, with practicality. But buried within Sumerian mathematics is something that does not belong to economics or agriculture. Something far too precise, far too persistent, to be explained by convenience alone. The Sumerians did not choose their numerical system because it was simple. They chose it because it was powerful. Their base 60 system, known today as sexagesimal, is often described as a clever solution to division. 60 has many factors. It divides neatly by 2, 3, 4, 5, and 6. This makes it useful for trade and geometry. That explanation is true. But it is incomplete. A base 10 system would have been far more intuitive for counting livestock or people. A base 12 system would have offered similar divisibility with less complexity. Yet the Sumerians committed fully to 60, embedding it into time, angles, calendars, and astronomy. Even today, we still live inside their choice. 60 seconds in a minute. 60 minutes in an hour. 360 degrees in a circle. These are not arbitrary survivals. They are remnants. To understand why 60 mattered, we must step away from daily life and look instead at cycles, long cycles that repeat imperfectly, demanding constant correction. Astronomy does not deal in neat integers. Planetary orbits drift. Lunar months do not align cleanly with solar years. Precession slowly alters the sky over thousands of years. Tracking these movements requires a system that can absorb fractions, remainders, and long accumulations without collapsing into chaos. Base 60 excels at this. It allows precise subdivision without losing coherence over time. It is forgiving of error, capable of adjustment, and ideally suited for long-term observational programs. This suggests that Sumerian mathematics was not invented for the marketplace. It was invented for the sky. When we examine Sumerian numerical tablets, a pattern emerges. Many contain values far larger than any practical need would require. Some tables list powers, squares, and reciprocal values extending far beyond everyday use. These are not teaching tools for beginners. They are reference documents, tools for specialists. And these specialists were not merchants. They were watchers. The same scribal class that maintained grain accounts also preserved long numerical sequences associated with celestial cycles. These numbers recur across generations with astonishing consistency. Errors are corrected. Deviations are flagged. Continuity is maintained. This is not casual numeracy. It is custodianship. One of the most intriguing numerical traditions in Sumerian culture is the use of extremely long time periods, units that far exceed a human lifespan. Kings are said to reign for tens of thousands of years. Ages are measured not in decades, but in vast, repeating spans. For centuries, these figures were dismissed as symbolic exaggeration, an attempt to glorify the distant past. But when these numbers are examined mathematically, they reveal something unexpected. They are structured. They are divisible. They fit neatly into larger cycles. The so-called antediluvian reign lengths are not random. They follow patterns consistent with base 60 arithmetic. When converted and aligned, they produce repeating intervals that correspond not to human history, but to astronomical rhythms. This suggests that these numbers were not meant to be taken literally as years lived by individuals. They were timestamps. Markers. Compressed records of time measured on a scale larger than human life. If Sumerian scribes were encoding celestial cycles into king lists and mythic chronologies, it would explain why these texts appear nonsensical when read as biography but coherent when read as timekeeping. Time, in this context, is not linear narrative. It is recurrence. One cycle ends. Another begins. The flood narratives reinforce this interpretation. They do not describe the end of time, but a reset. A clearing. A return to order after disruption. The same structures reappear. The same institutions are restored. This is not apocalypse. It is recovery. A civilization that believes the sky periodically disrupts the earth would not record history as a straight line of progress. It would record it as a series of cycles, each marked by collapse and reconstruction. Numbers become the only reliable memory. Words drift. Stories mutate. Numbers endure. The Sumerians understood this. Their obsession with precise counts, long intervals, and recurring totals suggests a culture attempting to preserve timing information across catastrophic loss. If libraries burned and cities fell, the numbers might survive, copied, repeated, embedded into tradition. Even if their meaning was forgotten, their structure would remain. This is how warnings persist beyond comprehension. Consider the Sumerian calendar. It was not a simple agricultural tool. It was a lunisolar system requiring constant correction. Intercalary months were inserted according to observed drift, not fixed rule. This demanded ongoing observation and comparison across years. Why accept such complexity and less accuracy mattered deeply? Agriculture tolerates drift. Ritual tolerates symbolism. Survival does not tolerate error. The calendar was a monitoring device. Its purpose was not merely to mark seasons, but to maintain alignment with the sky. If the calendar drifted too far, celestial events would no longer coincide with expected dates. Patterns would be lost. Warning windows would close. The cost of misalignment was not inconvenience. It was blindness. Sumerian texts frequently warn of losing the count. This phrase appears in administrative, religious, and astronomical contexts. Losing the count is treated not as a mistake, but as a danger. Counting was not accounting. It was defense. One text refers to a time when the count was broken and the sky surprised the land. This line has often been translated poetically, but its implications are chilling. Surprise is the enemy of preparedness. A sky that arrives unannounced is a sky that kills. This brings us back to the torrid cycles discussed in Part 4. Modern simulations suggest that dense filaments within the torrid stream drift over time. Their encounters with Earth are not annual certainties, but long-term probabilities. To anticipate periods of increased risk, one must track not just yearly passages, but multi-century oscillations influenced by planetary gravity. This is precisely the type of problem Base 60 mathematics excels at. Long cycles broken into manageable units. Fractions preserved without loss. Corrections applied gradually. The Sumerians did not need to know orbital mechanics in modern terms. They needed only to recognize that danger clustered. That centuries passed quietly. Then suddenly, conditions worsened. If they survived such a cluster, they would attempt to mark its recurrence. Not with dates, calendars drift. Not with stories, stories change. But with numbers. Large, repeating numbers. Embedded everywhere. So that forgetting would be difficult. This reframes the role of Sumerian priests and scribes. They were not mystics attempting to divine fate. They were custodians of temporal infrastructure. Their task was not prophecy. It was continuity. They inherited fragments of knowledge from a past rupture, knowledge that the sky occasionally behaves violently. They lacked the means to prevent it. All they could do was watch, count, and warn. Over generations, the reason behind the numbers may have faded. Ritual replaced understanding. Gods replaced mechanics. But the structure endured. This is how ancient knowledge survives catastrophe. It becomes tradition. It becomes sacred. It becomes untouchable. And therefore, it persists. Modern civilization prides itself on data, yet discards memory rapidly. Ancient civilization lacked technology, yet understood the value of redundancy. The Sumerians did not store knowledge in one place. They scattered it across myths, calendars, numbers, and architecture. To destroy it all would require destroying everything. Perhaps that is why it survived long enough for us to rediscover it. If Sumerian numbers encode long celestial cycles, then they were never abstract. They were warnings disguised as mathematics. And if that is true, then one final question remains. Did they encode not only that the sky returns to danger, but when? If the Sumerians believed time itself carried a schedule of destruction, then their greatest secret would not be written in myth or stone, but hidden in plain sight, inside the numbers we still use every day. Calendars are usually treated as harmless inventions. Tools to organize planting, taxation, ritual, and celebration. In modern thinking, they exist to structure human activity, not to respond to existential threat. Yet when examined closely, the Sumerian calendar refuses to fit comfortably into this assumption. It behaves less like a social convenience and more like an instrument designed to prevent something catastrophic from being forgotten. To understand why, we must abandon the idea that ancient calendars were primitive. The Sumerian calendar was not simple. It was unstable by design. It demanded constant correction, observation, and human intervention. This alone makes it unusual. Simpler calendars existed and would have sufficed for agriculture. Many cultures accepted drift, allowing seasons and festivals to slowly slide out of alignment before reforming them generations later. The Sumerians did not allow this. Their calendar was lunisolar, meaning it attempted to reconcile the lunar month with the solar year, two cycles that do not align cleanly. 12 lunar months fall short of a solar year by roughly 11 days. Over time, this discrepancy accumulates, causing seasons to drift and less corrective months are added. The Sumerians inserted these intercalary months not according to fixed rules, but according to observation. This is critical. It meant someone had to watch the sky continuously. Someone had to compare expected celestial positions with actual ones. Someone had to decide when alignment had drifted too far to be tolerated. This was not ritual laziness. It was vigilance. In many Sumerian texts, calendar correction is treated with solemn importance. Errors are recorded. Adjustments are justified. The act of restoring alignment is framed not merely as administrative competence, but as cosmic responsibility. Why would calendar accuracy matter this much unless misalignment carried consequences? Agriculture does not collapse if a festival slips a week. Ritual meaning survives symbolic error. But prediction does not. If the calendar was being used to anticipate dangerous celestial windows, periods when Earth passed through regions of increased risk, then drift would be catastrophic. It would cause watchers to look at the wrong time. The sky would arrive unannounced. This brings us back to a phrase that appears repeatedly in Sumerian records: the day must not be lost. This phrase has often been translated as religious anxiety, fear of offending the gods by missing a ritual date. But in administrative and astronomical contexts, it carries a sharper edge. Losing the day is associated with surprise, disorder, and devastation. The day is not symbolic. It is temporal alignment. The Sumerians were obsessed with beginnings. The first day of a month. The first rising of a star. The first appearance of Venus after absence. These were not celebrations. They were checkpoints. Venus, in particular, occupies a troubling place in Sumerian astronomy. It is tracked obsessively. Its appearances and disappearances are logged with precision unmatched by any other planet. The famous Venus tablets of Amasuduka record its heliacal risings and settings across decades. For centuries, scholars treated these records as astrological curiosity. But the language used is not mystical. It is logistical. Deviations are noted. Anomalies are flagged. The concern is not what Venus means, but whether it appears when expected. Venus is bright. It dominates dawn and dusk. It appears close to the Sun, precisely the region of the sky from which dangerous objects are hardest to detect. If a civilization feared objects emerging from solar glare, Venus would become a critical marker. Its behavior would signal whether the sky was behaving normally or deviating. Deviation matters. The Sumerians tracked not only where Venus appeared, but how long it remained invisible. Prolonged absence is treated with concern. Unexpected reappearance triggers warnings. This is not symbolic interpretation. It is anomaly detection. The calendar ties directly into this monitoring. Venus cycles do not align neatly with lunar months. Reconciling them requires long-term counting. Errors compound quickly. Only a flexible, observation-driven calendar could sustain this task. This again raises an uncomfortable conclusion. The calendar was not built for festivals. Festivals were built around the calendar. The true function lay beneath the ritual surface. The Sumerian New Year, often described as a celebration of renewal, coincides with a period of celestial transition. It marks not only seasonal change, but the resetting of observational cycles. Accounts are closed. Counts are renewed. Watchers begin again. This is not symbolic rebirth. It is operational reset. Many Sumerian rituals involve purification, silence, and suspension of normal activity. These periods align with astronomical thresholds, eclipses, planetary conjunctions, or times when visibility is compromised. Silence is not worship. Silence is caution. In one text, a city is instructed to remain still when the sky is unsettled. Movement is discouraged. Travel ceases. Fires are extinguished. This has often been interpreted as appeasement of gods. But from a practical standpoint, it reads like sheltering behavior. Shockwaves flatten walls. Heat ignites roofs. Remaining indoors increases survival. The calendar did not merely mark time. It regulated behavior. This regulation becomes clearer when we examine how Sumerian months were named. Many are tied not to agricultural activity but to celestial events. The month the star appears. The month the light returns. The month of the burning wind. These are not poetic inventions. They are reminders. Reminders of when to watch closely. Reminders of when danger once appeared. Reminders of what happened last time. The repetition of these names across centuries suggests that the memory they preserved remained relevant. If centuries passed without incident, the calendar would lose urgency. Names would change. Rituals would soften. They did not. The same months retained the same warnings. This suggests that the threat was not imagined. It was expected. Another revealing feature of the Sumerian calendar is its relationship with eclipses. Lunar and solar eclipses are recorded meticulously, often with accompanying warnings. Modern readers often treat eclipse fear as superstition. But eclipses serve as precise timing markers. They anchor calendars. They provide fixed reference points in the sky. They allow long-term counts to be corrected. If a civilization was tracking multi-century celestial cycles, eclipses would be invaluable. They provide moments of alignment that can be verified visually across generations. The Sumerians treated eclipses not merely as omens, but as checkpoints. This reinforces the idea that their timekeeping was fundamentally defensive. They were not predicting fate. They were maintaining readiness. The calendar was the spine of this system. Lose the calendar, and you lose alignment. Lose alignment, and you lose warning. Lose warning, and history repeats itself without preparation. This is why calendar reform was dangerous. Changes were resisted. Innovations were slow. Stability mattered more than efficiency. This also explains why Sumerian timekeeping influenced later cultures so deeply. Babylon inherited it. Greece adapted it. Rome absorbed fragments of it. Modern time itself still carries its structure. This is not because 60 is elegant. It is because 60 was essential. The Sumerians understood something that modern civilization struggles to accept: progress does not erase risk. Knowledge does not eliminate vulnerability. The sky does not care how advanced a culture becomes. Only vigilance persists. The calendar was their most powerful tool of vigilance. It trained every generation to live inside cycles rather than illusions of permanence. It taught people that time returns. That danger clusters. That forgetting is fatal. If this seems paranoid, consider the alternative. A civilization that experiences cosmic catastrophe and learns nothing from it does not survive long enough to pass on lessons. Sumer survived. Not because it was lucky, but because it remembered. And because it built that memory into time itself. Which leads us to the most disturbing implication of all. If the Sumerian calendar encoded periods of heightened risk, and if those periods recur, then the calendar was not merely historical. It was predictive. The counts did not end with Sumer. They were inherited, adjusted, passed on. And at some point, they began to drift from their original meaning, not because the numbers were wrong, but because the reason for them faded. We still use their numbers. We no longer know why. If the Sumerians used calendars to preserve warning across millennia, then the final layer of this story is unavoidable. At what point did humanity stop watching the sky as a threat, and did that decision leave us blind at the worst possible moment? There is a precise moment in human history when vigilance quietly gave way to confidence. It was not announced. No decree marked it. No civilization consciously decided that the sky was no longer dangerous. The transition happened gradually, almost politely, as knowledge transformed into belief, and belief into assumption. The Sumerians lived beneath a sky they did not trust. Their descendants inherited fragments of that distrust, but not its urgency. Over centuries, the memory of cosmic threat did not vanish, it softened. What was once operational knowledge became ritual. What was once vigilance became symbolism. and what was once survival strategy was eventually reclassified as myth. This process did not occur because humanity became wiser. It occurred because nothing happened for a very long time. When catastrophe does not repeat within living memory, its threat begins to feel theoretical. Even a civilization built around cycles cannot sustain fear indefinitely without reinforcement. Generations are born, live, and die under calm skies. The absence of disaster becomes evidence of safety. Vigilance begins to feel unnecessary, even wasteful. This is the most dangerous phase of any long cycle. Later Babylonian texts preserve Sumerian astronomical knowledge with extraordinary precision, yet their emphasis changes. Observation gives way to interpretation. Measurement gives way to divination. The sky is still watched, but now primarily for meaning, not threat. The difference is crucial. To watch for meaning is to assume the sky speaks symbolically. To watch for threat is to assume the sky behaves mechanically. One invites interpretation. The other demands preparedness. As Babylon rose, astronomy became increasingly entangled with astrology. Celestial events were still recorded, but their consequences were framed politically or morally. An eclipse no longer signaled atmospheric alignment or temporal correction, it signaled the fall of a king or the displeasure of a god. This shift did not eliminate vigilance. It redirected it. The sky was no longer dangerous to humanity as a whole. It was dangerous to rulers, to dynasties, to legitimacy. The focus narrowed. Collective survival gave way to political forecasting. This transformation marked the beginning of humanity's long retreat from cosmic realism. By the time Greek philosophy absorbed Near Eastern knowledge, the transition was nearly complete. Greek thinkers inherited the mathematics and geometry of Mesopotamia, but stripped it of existential urgency. The heavens became perfect, immutable, divine. Change belonged to Earth alone. Aristotle's cosmos was elegant and catastrophically wrong. In this worldview, the heavens could not be corruptible. Celestial spheres were eternal. Perfect. Unchanging. Any suggestion that the sky could threaten Earth became philosophically unacceptable. Meteors were reclassified as atmospheric phenomena. Fireballs were dismissed as terrestrial vapors igniting in the upper air. The sky was declared innocent. This idea would dominate Western thought for nearly 2,000 years. It did not matter that people occasionally witnessed fire falling from above. It did not matter that comets appeared unexpectedly, moving against the supposedly perfect spheres. These were anomalies to be explained away, not warnings to be investigated. The philosophical commitment to a harmless sky became stronger than the evidence against it. Rome inherited this worldview and codified it. Knowledge was preserved, but curiosity was constrained. Observation was permitted only insofar as it reinforced established cosmology. Anything that contradicted celestial perfection was marginalized. By the time the medieval world inherited this legacy, the sky was no longer feared. It was revered. Ironically, this reverence made it invisible as a threat. When medieval chroniclers described strange lights, falling stones, or sudden darkness, their accounts were treated as divine portents, not physical phenomena. No systematic effort was made to catalogue or understand them. The observational discipline of Sumer had vanished. The watchers were gone. The calendar remained. The numbers remained. But the reason for them did not. Even when the scientific revolution shattered Aristotelian cosmology, it did not immediately restore vigilance. Copernicus, Kepler, and Galileo revealed that Earth moved, that the heavens were dynamic, but the idea of cosmic threat remained uncomfortable. Newton's universe was governed by laws, but those laws were perceived as stable and predictable. Catastrophe was still considered rare, exceptional, almost impossible on human timescales. Uniformitarianism, the belief that Earth's processes change slowly and gradually, became the foundation of modern geology. The past was interpreted through the lens of the present. If catastrophe was not observed, it was assumed not to occur. This assumption felt rational. It was also profoundly misleading. The absence of evidence was mistaken for evidence of absence. The Earth, however, kept its own record. In the 19th century, strange discoveries began to surface. Fossil layers filled with extinct species. Sudden boundaries separating radically different ecosystems. Massive erratic boulders transported far from any plausible source. These anomalies challenged gradualism. But the resistance was fierce. Catastrophe was associated with theology, with flood myths, with unscientific thinking. To accept it felt like regression. Science chose comfort over confrontation. Even when craters were identified on the Moon, they were not immediately recognized as impact scars. Lunar craters were explained as volcanic features long after evidence contradicted that view. The idea that Earth could be struck repeatedly by extraterrestrial objects remained fringe. It was easier to believe Earth was special. It was easier to believe disaster belonged to the distant past. It was easier to believe the sky had calmed. The 20th century finally forced a reckoning. Nuclear weapons revealed that airbursts could devastate cities without leaving craters. The Tunguska event could no longer be dismissed. Space exploration revealed a solar system filled with debris, impact scars on every planetary surface except one, Earth. Earth's scars were hidden by erosion, plate tectonics, and time. But they existed. The discovery of the Chicxulub crater, linked to the extinction of the dinosaurs, shattered the last illusions. Catastrophe was no longer mythological. It was geological. Yet even then, humanity compartmentalized the threat. Impacts were framed as rare, deep-time events. Millions of years apart. Nothing to worry about. Once again, the long calm was mistaken for safety. This is the same error previous civilizations made, but with far higher stakes. Modern humanity is more technologically advanced than any civilization before it. It is also more interconnected, more fragile, and more dependent on uninterrupted systems. Electricity, satellites, global supply chains, all vulnerable to sudden atmospheric disruption. A cosmic airburst today would not merely flatten cities. It would blind civilization. Satellites would fail. Communications would collapse. Power grids would destabilize. Aviation would halt. Agriculture would suffer global consequences. The Sumerians built redundancy into clay and ritual. Modern civilization builds efficiency into silicon and software. Efficiency fails catastrophically under surprise. This is why the loss of vigilance matters more now than it ever did before. The Sumerians assumed the sky could strike again. Modern humanity assumes it will not. This assumption is not based on evidence. It is based on comfort. The same torrid stream Earth has passed through for tens of thousands of years still exists. The same gravitational dynamics still operate. The same clustering of debris still occurs. The difference is not the sky. It is us. We no longer organize society around cycles of risk. We no longer train generations to watch transitional skies. We no longer treat calendars as warning systems. We treat them as scheduling tools. And yet, quietly, the data accumulates. Near-Earth objects are catalogued faster than ever before. Each year, more are discovered passing uncomfortably close to Earth. Some arrive undetected until after they pass. Others are discovered days or hours before closest approach. Many approach from the direction of the sun. Exactly where ancient watchers focused their attention. The modern response is technological optimism. Detection systems. Deflection proposals. Committees. Funding cycles. Risk assessments. All valuable. All incomplete. Because technology does not replace awareness. It supplements it. The most dangerous assumption is that danger will announce itself clearly and early. The Sumerians did not assume that. They assumed surprise was inevitable. And so they prepared for it. This is the lesson humanity unlearned. Not because it was wrong, but because it was uncomfortable. We prefer narratives of progress to narratives of recurrence. We prefer linear time to cyclical vulnerability. We prefer to believe we have outgrown ancient fears. But the sky does not care what we prefer. It has no memory. It follows physics. And physics does not negotiate. The Sumerians watched because they remembered something we forgot, that civilization exists at the mercy of forces that do not scale with technology or intelligence. The moment humanity stopped watching the sky as a threat was not a triumph. It was a gamble. And like all gambles, it works until it doesn't. If ancient civilization structured time itself around the expectation of cosmic return, and modern civilization has abandoned that expectation, then the final question becomes impossible to avoid. When the sky next reminds us that it has never been harmless, will we recognize the warning, or repeat the mistake of believing it cannot happen again? For most of human history, ignorance was unavoidable. The sky could not be measured with precision. Objects moved without explanation. Danger arrived without warning. When catastrophe struck, it was attributed to gods, fate, or chaos. Modern civilization, by contrast, has no such excuse. We live in an age of sensors, simulations, telescopes, and constant surveillance. We map the heavens continuously. We catalogue near-Earth objects. We model orbital dynamic centuries into the future. And yet, despite all this capability, humanity remains strangely reluctant to confront what the data actually implies. The problem is not a lack of information. It is interpretation. Modern astronomy has confirmed beyond doubt that Earth resides in a shooting gallery. The solar system is not a clean, orderly machine. It is cluttered with debris, asteroids, comet fragments, dormant nuclei, and dust streams that crisscross planetary orbits. Earth's path around the Sun intersects multiple such streams every year. Most encounters are harmless. Some are not. The distinction between harmless and catastrophic is not gradual. It is threshold-based. A difference of a few meters in object size can mean the difference between a meteor and a city-leveling airburst. A difference of angle can determine whether an object burns up silently or detonates with explosive force. These are not uncertainties that can be smoothed away statistically. They are discontinuities. Modern impact risk assessment struggles with this reality. Most risk models assume randomness. Objects are treated as isolated points with independent probabilities. But the solar system does not behave randomly. It behaves dynamically. Objects cluster. Streams persist. Fragmentation creates families of related debris moving together through space. This is precisely what ancient watchers appeared to understand intuitively. Modern science is only now catching up. The Taurid meteor complex, discussed earlier, is no longer fringe speculation. It is recognized as one of the most massive and persistent debris systems intersecting Earth's orbit. Astronomers have identified large asteroids embedded within the Taurid stream, objects hundreds of meters wide, moving on orbits that periodically bring them dangerously close to Earth. Some of these objects are classified as potentially hazardous asteroids. That designation alone should command attention. But what matters more is the structure of the stream itself. The Taurids are not evenly distributed. They contain dense filaments, concentrations of material that Earth intersects episodically. These encounters do not occur every year. They cluster on timescales of centuries to millennia. When Earth passes through a dense filament, impact probability increases dramatically. This is not speculation. It is orbital mechanics. Recent modeling suggests that Earth entered a denser region of the Taurid stream in the late 20th century and will remain within it for several centuries. This does not guarantee catastrophe. But it increases the likelihood of significant airbursts compared to background levels. This fact is often downplayed. Not because it is uncertain, but because it is inconvenient. Risk that cannot be easily mitigated challenges the narrative of control. Modern civilization prefers problems it can solve technologically. It prefers threats with clear countermeasures. Cosmic risk does not behave that way. Detection systems are improving, but they are not omniscient. Many objects approach from near the Sun's direction, where telescopes struggle to observe. Even large objects can remain undetected until days or hours before closest approach. This is not a failure of competence. It is a limitation of geometry. The same blind spots that worried ancient sky watchers still exist. We know this because objects continue to surprise us. In 2002, an asteroid roughly 50 meters wide passed closer than the Moon without being detected in advance. In 2019, another similar object approached from the Sun's direction, unnoticed until after it had passed. In 2022, a small asteroid struck Earth over the Arctic with no prior warning, detected only because military sensors recorded the explosion. These were small events. They are also reminders. Modern detection networks are impressive, but incomplete. They prioritize certain orbital regions and size thresholds. Smaller objects, those capable of regional devastation, often fall below detection limits until it is too late. The Chelyabinsk event demonstrated this brutally. A 20-meter object exploded over a city of over 1 million people. It arrived from the Sun's direction. No warning was issued. No evacuation was possible. Had it arrived at a steeper angle or at night, the outcome would have been far worse. This was not a freak anomaly. It was a preview. The energy released over Chelyabinsk was equivalent to several hundred kilotons of TNT. Tunguska was an order of magnitude larger. Events of that scale are expected on timescales of centuries, not millions of years. This is not alarmism. It is consensus. And yet, public awareness remains minimal. The reason is not ignorance among scientists. It is communication failure driven by institutional caution. Cosmic risk is difficult to convey without sounding speculative or sensational. Funding agencies prefer conservative language. Governments avoid topics that imply vulnerability beyond political control. So the story is softened. Risks are framed as remote. Probabilities are averaged. Timeframes are stretched. This mirrors exactly what happened in ancient times when vigilance softened into ritual. The data exists. The urgency fades. There is another layer of discomfort that rarely enters public discussion. Impact risk is not evenly distributed across time. It clusters. The same gravitational dynamics that create debris streams also create windows of elevated risk. Jupiter's influence shepherds fragments into resonant orbits. These resonances persist. They drift slowly. When Earth intersects them, risk rises. This is not controversial in celestial mechanics. What is controversial is acknowledging that these windows may coincide with historical catastrophe clusters. The Younger Dryas is one such cluster. There are others. Around 2200 BCE, multiple civilizations experienced abrupt collapse. The Akkadian Empire fell. Egypt's Old Kingdom destabilized. Climate proxies indicate sudden aridification, cooling, and dust loading. Ancient texts describe darkness, famine, and societal breakdown. This period aligns disturbingly well with descriptions preserved in Near Eastern traditions. Once again, the explanation is fragmented: climate change, social complexity, internal instability. These explanations are not wrong. They are incomplete. Climate does not change without cause. Dust does not appear without mechanism. Collapse does not synchronize across regions without shared stressors. Cosmic airbursts provide a mechanism capable of triggering all three. They ignite fires, inject dust, disrupt climate, and destabilize societies already operating near their limits. This does not require a global extinction event. It requires disruption. Civilization is fragile. Modern civilization is even more so. The interconnectedness that makes it powerful also makes it vulnerable to cascading failure. A regional disaster today does not remain regional. Supply chains fracture. Markets react. Political systems destabilize. The Sumerians understood fragility instinctively. Modern humanity assumes resilience. This assumption has not been tested under cosmic stress. There is another uncomfortable reality embedded in modern data. We are not merely passive observers of cosmic risk. We are amplifying its consequences. Urbanization concentrates population. Infrastructure centralizes power generation. Satellites create single points of failure for navigation, communication, and finance. Agriculture relies on predictable climate and global logistics. A Tunguska-scale airburst over a major metropolitan region would produce consequences far beyond physical damage. The psychological shock alone would ripple globally. Markets would crash. Trust would erode. Governments would scramble. Information would fragment. The Sumerians built decentralized systems precisely to survive disruption. Modern civilization builds centralized systems precisely because disruption has been absent for so long. This is the paradox of progress. The longer catastrophe is absent, the more vulnerable civilization becomes to its return. Modern risk models struggle to incorporate this sociological dimension. They calculate impact probability but not impact amplification. They assess energy release but not systemic fragility. Ancient societies could absorb regional devastation because they expected it. We do not. Another blind spot emerges when we examine how modern science categorizes risk temporally. Threats are often divided into short-term and long-term. Short-term threats receive funding. Long-term threats are deferred. Cosmic impacts are typically classified as long-term, future problems, unlikely within political cycles. But this classification is misleading. The probability distribution is not linear. It is spiky. Low background risk punctuated by sudden, unpredictable spikes. This is exactly how ancient calendars behaved. Long calm periods. Then disruption. Then calm again. The Sumerians built systems to endure calm without forgetting danger. Modern systems are optimized to exploit calm and assume continuity. This is the critical divergence. Even today, when scientists model impact risk honestly, the conclusions are uncomfortable. Mitigation is theoretically possible for large objects detected years in advance. It is not feasible for objects detected days or hours in advance. Most dangerous airbursts fall into the latter category. There is no planetary defense against surprise. Only preparedness reduces harm. Preparedness requires cultural memory. Cultural memory requires acknowledgement. Acknowledgement requires courage. The Sumerians had that courage because they had seen what happens without it. We have not. We rely on the assumption that because nothing has happened recently, nothing will happen soon. This is not a scientific assumption. It is a psychological one. The data does not promise safety. It merely records calm. Calm is not evidence. It is absence. And absence has misled humanity before. The sky has not changed. Earth still crosses debris streams. Fragments still drift. Resonances still cluster. The same physics that governed the ancient world governs ours. The difference lies in how we choose to interpret what we see. The Sumerians looked at the sky and saw recurrence. Modern humanity looks at the same sky and sees background noise. Both interpretations are choices. Only one aligns with physics. If modern data confirms that cosmic danger has not vanished, only been statistically quiet, then the final layer of this investigation becomes unavoidable. What did ancient civilizations do when they believed the next cycle was approaching, and what would that knowledge mean for us now? The sky above us has not changed its habits. It still turns with silent precision. Stars still rise, drift, and vanish beyond the horizon as they always have. What has changed is not the heavens, it is us. For most of human history, the night sky was not background decoration. It was a presence. A system that demanded attention. A force capable of beauty, guidance, and destruction in equal measure. The Sumerians understood this in a way few civilizations ever did. They did not romanticize the cosmos. They did not trust it. They watched it. Their tablets do not read like myths invented to comfort frightened minds. They read like records written by people who had already learned the cost of ignoring the sky. People who believed, with quiet certainty, that danger did not arrive randomly, it returned. What they feared was not the end of everything. It was the reset. A civilization erased not by moral failure or divine anger, but by forces that operate far beyond human intention. Fire without flame. Darkness without storm. Silence without warning. They built their world around that understanding. They counted when others prayed. They measured when others mythologized. They embedded vigilance into architecture, ritual, and language itself. Not because they believed they could stop the sky, but because they believed awareness was the only defense humanity had. And then, slowly, that awareness faded. Empires rose and fell. Languages shifted. Meanings softened. The gods remained, but the reason for watching them changed. What began as surveillance became ceremony. What began as warning became story. What began as fear became symbolism. Yet the structure endured. The temples still pointed toward the same horizons. The calendars still pulled eyes upward at the same moments. The myth still whispered of fire, wind, and darkness, even when no one remembered why. That is the most unsettling legacy of Sumer. Not what they knew, but how deliberately they assumed that knowledge would be lost. They expected forgetting. That expectation shaped everything they built. Modern civilization does not share that assumption. We believe knowledge accumulates. That once a risk is identified, it remains identified forever. That data is permanent, and memory is secure. History tells a different story. Libraries burn. Institutions collapse. Expertise fragments. Warnings become footnotes. The Sumerians understood that memory does not survive by accident. It survives only if it is made unavoidable. Today, the sky is watched by machines rather than priests. Satellites scan. Algorithms calculate. Databases expand quietly in secure facilities far from public awareness. This is progress, but it is also distance. We experience cosmic risk as probability, as abstract percentages buried in technical reports, as simulations discussed in conference rooms. The Sumerians experienced it as environment. For them, the sky was not something that might become dangerous. It was something that already had been. And in recent years, modern science has begun to circle back toward that ancient perspective. Near-Earth object catalogs grow larger every year. Meteor airbursts are no longer theoretical. They are observed, measured, recorded. We now understand debris streams, fragmented comets, clusters of objects shepherded by gravity into recurring paths. We understand that impacts do not arrive evenly across time. They cluster. They recur. They follow rhythms written into orbital mechanics, not fate. The language is different now. But the message is familiar. The sky does not forget its cycles. And it does not care whether anyone remembers them. The most striking similarity between modern planetary defense science and ancient Sumerian astronomy is not the data. It is the mindset. Both operate on the same assumption: that catastrophe is not a question of if, but when and how prepared. The difference is scale. The Sumerians built vigilance into daily life. We outsource it. They made observation sacred. We make it specialized. They assumed collapse was possible. We assume continuity. And that assumption may be our greatest risk. Because systems that rely on uninterrupted stability are fragile by design. The Sumerians did not expect their civilization to last forever. That is why parts of it did. They planned for interruption, for loss, for the moment when the watcher would need to be replaced. In that sense, their message was never meant only for their own time. It was meant for strangers. For people who would inherit the sky without inheriting the fear. For people like us, standing beneath the same stars, with better tools, more data, and less instinctive attention. The sky today appears calm. Most nights pass without incident, just as they did in ancient Mesopotamia. And that is precisely why vigilance fades. Catastrophe does not announce itself with permanence. It arrives briefly, then leaves behind silence long enough for complacency to take root. The Sumerians understood that silence was dangerous, that the most destructive intervals were not the moments of fire, but the centuries afterward, when nothing seemed to happen, and people stopped watching. Their civilization was built not around panic, but around patience. Around the idea that the sky could be quiet for a very long time, and then suddenly not be. This is why their final legacy is not prediction, but posture. A way of standing beneath the heavens. Eyes open. Counts maintained. Memory externalized. They did not ask whether disaster would come. They asked whether anyone would notice when the signs returned. That question remains unanswered. Because the sky is still there. The debris still moves. The cycles still unfold. Whether we experience them as spectacle or catastrophe depends not on fate, but on attention. As you listen now, perhaps in darkness, perhaps with the day fading at the edges of awareness, consider where you are, what time it is, what part of the sky is above you. The Sumerians would have noticed that too. Not out of ritual. Out of responsibility. They believed that watching was an obligation inherited across generations. That survival depended not on strength, but on remembering what others had already learned the hard way. Their warning was never loud. It was quiet. Persistent. Patient. It said only this: the sky has done this before. It will do it again. And the difference between survival and surprise is whether anyone is still paying attention. That watch has never truly ended. It has only changed hands. The question now is simple and profoundly ancient. Who is watching today?